C2 Trigonometry Section 2 Example 3. So here we have an emblem which consists of a triangle ABC joined to the sector CBD of a circle with radius 4 and centre B. So that means that this side is 4 centimetres and so is this side. So the points ABD lie on a straight line with AB being 5 centimetres and BD being 4 centimetres. Angle BAC is equal to 0.6 radians, so that's put on the diagram here for you, and AC is the longest side of the triangle ABC. So the first thing that we need to do is show that angle ABC is equal to 1.76 radians to three significant figures. So for A, the first thing we need to do is look at the triangle. So just a quick sketch. We know that this is 0.6 radians. We know that this side is 4 centimetres and that this side is 5 centimetres. This angle here is capital A, this is capital C, this is capital B, and of course the opposite angles get the opposite sides to the angles get the lowercase letters. So this one will be B, this one would be A, and this one would be lowercase c. So we'll have to start off by finding the angle at C, because we can do this by doing sine of angle C over side C would be equal to sine of capital A over A, using the sine rule. So rearranging this, that means that sine C would be equal to C sine A over A. And substituting in what we know, that means that sine C would be equal to 5 sine of 0.6 radians all over 4. And if I put that into my calculator and inverse sine it, we get C equals, of course, it would be inverse sine of 5 sine 0.6 radians over 4, which is equal to 0.7836 radians. So we found this angle here, but of course we want the angle ABC, so that's this angle here. So we all know that angles in a triangle add up to 180 degrees. So we know that 180 degrees is also equal to pi. So the angles in the triangle, because we're measuring in radians, should add up to pi. So that would be 0.6 plus 0.7836. And of course, we'd have to subtract that from pi to get what the missing angle is. So that would give us 1.7580 radians. But of course, we only want our answer correct to three significant figures. So that gives an answer of 1.76 radians. Now for question B, we're asked to find the area of the emblem. So you can probably guess that we're going to have to find the area of the triangle and the area of the sector and then add them together. So for part B, we're going to have to find the area of the triangle So I've just drawn a rough sketch of the shape so that I can annotate it. So I know that this is 0.6 radians. I know that this here is 0.78 radians. I know that this here is 0.76 radians. Sorry, that's 1.76 radians. I know that the length of this side is 5 and these two sides are length 4. So the first thing that we need to do is find what theta is here. So then we know the angle for our sector, because then we know r and theta, and then we can figure out the area of it. So theta will be equal to, again, remembering that pi is equal to 180 degrees, pi minus 1.76, which gives us an answer of 1.38 radians. So the area of the sector, which is equal to a half r squared theta, would be equal to a half of 4 squared times 1.38. And typing that into your calculator gives you an answer of 11.053 centimetres squared. So we've got the area of our sector. Now we need to find the area of our triangle. So area of the triangle would be equal to, again, from our sine and cosine booklet, it'd be equal to a half AB sine C. So that would be a half of 5 times 4 sine of 1.76. And typing that into your calculator would give you an area of 9.8215 centimetres squared. So the total area of the emblem would be equal to 11.053 plus 9.8215, which gives us a total area of 20.87 centimetres squared. And that's correct to 2 decimal places.